Hello, how do you do? My name is Lasse Jonsson and I work for a company called Timebeat, and we do hardware and software that will keep your network in perfect sync. Have you ever noticed how things that have state typically rely on consensus? More than one copy of something is required for you to know that it really is in a particular way. In Kubernetes, for instance, it relies on etcd. In Elasticsearch, if you've ever seen a master node election takes place, it's 3. Redis Raf, for instance, Influx, all relies on consensus. And so it is with UTC, right? It's something that arises from 400 different clocks across the world in something like 80 different locations. Even at NIST, just in the US, there's 10 to 15 clocks, okay? They all get mixed together with a weighted average, and then out comes one thing. But it is based on consensus, right? And after that, the time goes into 4 different GNSS constellations, okay? So in the data center, if you have a PTP Grandmaster clock, right, it looks at 20 to 40 satellites in parallel. It looks at maybe 80 different signals, okay? Consensus. But then we get to the data center, and the paradigm, for inexplicable reasons, changes completely, where absolutely every link, every node is a single point of failure. If a boundary clock fails, everything which is downstream from it, right? It doesn't work. Time error can be injected through these failures without you noticing. And Timebeat is really a company that sort of entered the clock synchronization space because we thought the industry in general had too little innovation and was enjoying too high margins, okay? So what we really propose is to extend the consensus model into the data center, okay? To get rid of this idea that you only have to look at one thing at a time. Instead, we've made 3 clocks that are completely independent. They sit next to each other in one rack unit, right? And by the way, this one rack unit with 3 clocks, it costs about half of what our competitors charge for 1 clock. Okay, and so the way we've designed it is dual network ports, so you can connect it to redundant network fabrics, right? On the back, as we come around, you can see we have some input and output ports in the back. Okay, this allows you to compare time with the other clock in this clock ensemble, right? Every one clock here can see the output of every other clock, right? Which is a really handy thing. Inside is completely modular. Okay, we have oscillators from different vendors. We have GNSS receivers from different vendors. Right, in the oscillator space, we have dual Oven OCXOs. They are the highest end OCXOs you can get. The atomic clocks are either Rubidium or Cesium, right? And for the GNSS chips, okay, it's very nice that you can have different vendors, right? And then we do this east-west thing, so you have an opportunity to compare the clocks, right? And they look small, right? We have a background in making PCIe cards. So we managed to shrink everything down to a reasonable size, right? There's, and by the way, redundant power as well, so you can power it in the front, power it in the back. If you pull one out, it still keeps running, right? So they are smaller, right? Less than 5 inches wide, but they are not less powerful. There's some real stake inside these clocks. And they have a variety of uses, right? So not just as this consensus model, but actually some of our customers as well, they use them in exchanges where it's not uncommon to not have access to GNSS, and instead you receive some PTP feeds from the exchange, right? And what some people are realizing and experiencing to their detriment is that sometimes those PTP feeds from an exchange, they don't agree with each other, i.e. you stop having that consensus. But with this, if you look at them in parallel, okay, then you can see that suppose they agree with each other, okay, everything is hunky-dory, but the moment we no longer have that 2 or more consensus, we go into holdover because we cannot trust a single thing, okay? That is the basic premise of everything that we do. So there we go. So that's another use of the technology. We're very proud of it. We'd love for you to come and talk more to us at our standard stack today. If you decide to do that, you can play our amazing clock puzzle game. Okay, and there's a prize in the end if you do well. Or you can have one of our open time business cards. So it'd be great if you come and just take a look. Thank you very much. I really appreciate your time.